You may not understand that, but as we go through this, you'll start to understand more and more why that is the case. Let me clarify this. Here is a better drawing of what I was talking about before and the different phases. There's phase 4, which is at rest. As we talked about before, the cell is very negative. In this case, it's at 96 millivolts. And the reason for that is because there is potassium that is leaking outwards. Okay? Now, what happens is that there is some event that occurs where the sodium channels open up, and you can see here clearly that the sodium channels are opening up. That causes a positive charge to rush into the cells, and that causes depolarization. And at this point, you can see here that the potassium channels are still allowing the potassium to go out. There is a calcium which comes into the cell. Potassium is still leaving. And then finally, we have something called repolarization, where, as we mentioned, potassium is still leaking out, but we have a bunch of potassium rectifiers that are pumping that potassium back in. So we have slow delayed rectifier, rapid delayed rectifier, and inward rectifier. We don't need to know those, but as those potassium cells are actually basically leaving, potassium is leaving, that's going to cause this to become more negative and back down to repolarization. But more specifically, the sodium itself is being pumped out, and you have a repolarization, and then finally here you're back down to where you were.